to study about equations of motion. First, in physics, there are some equations which are related to motion that are called equations of motion. And first, I wish to know about, I wish to teach you two terms again, which is U and V. Okay, V is the final velocity of a body and U is the initial velocity of a body, which means at the starting point of a motion, a body possesses a velocity. ഒരു ബോഡിയുടെ സ്റ്റാർട്ടിംഗ് പോയിന്റിൽ ഒരു മോഷൻ്റെ സ്റ്റാർട്ടിങ്ങിലുള്ള വെലോസിറ്റീനെ വി ആർ ടേംഡ് ഇറ്റ് ആസ് ഇനീഷ്യൽ വെലോസിറ്റി. ഓക്കെ, ഒരു ബോഡിയുടെ while the motion ends, at that moment that body possesses one velocity, that is what the final velocity. I hope it's clear. Initial velocity and final velocity. Initial velocity means starting velocity of the body, and the letter which is used to denote the initial velocity is U. Okay, final velocity is what? V. And we already studied about acceleration. When velocity changes, acceleration comes. And time. Now we know displacement. So displacement we are denoting by the letter S, which means equations of motions are the motions connecting all these terms. How many terms you can see? The displacement S, initial velocity U, final velocity V, acceleration A, and the time T. Okay, equation connecting all these terms, which is called equations of motion, and in physics we have three equations of motion. Okay, already I think it's clear to you. Now we are going to study the first equation of motion. For that you can see a velocity time here, some values of velocity and some values of time here, and the same I am going to plot in this graph. Okay, velocity I am taking in the y-axis and the time I am taking in the x-axis here. And also you have to note down one thing. What is initial velocity of this motion? Initial velocity is, if it is in kilometer per hour, initial velocity of this motion is 3 kilometer per hour. Okay, now if it so 3 is the initial velocity U for this body. Now what's the final velocity of the body? At the end of the motion, the body is possessing a velocity of 15. So final velocity is 15. So it's clear the U and V terms. First velocity, at the starting point of a motion, what's the velocity of a body? That is what? U. At the end of a motion, what's the velocity of the body? That is V. So U, V, it's clear. Now I am going to plot all these values in a graph. You will get a straight line like this. You can just see the points. First is 3, 0. So the first ordered pair is this 3, 0. Okay. Initially there is a velocity for this body. Now the second ordered pair is 6, 4. So the same 6, 4 I am plotting here. Now the third velocity is 9, 6. So the third velocity I am plotting here. This is the point. And the fourth velocity 12, 8. 12, 8. This is the fourth velocity. And the final point ordered pair is 15, 10. So after plotting all this point here, we will get a graph like this. Okay. Now I wish to mark initial velocity and final velocity, which is U and V here in this graph. Okay, initial velocity we know 3. So this is what the initial velocity. Am I right? 3. This distance is what the 3. So this is what the initial velocity U. So I'm going to give a name for this point, which is A. So what is the initial velocity for this body? Initial velocity U for this body is OA. Am I right? 3 is the initial velocity, so I just named it as this point as A. So OA is the initial velocity. Now, what's the final velocity for this body? Final velocity for this body is 15. So how we can locate this 15 here? This distance is what the final velocity. I am giving a point name like this, BC. Okay, so this length, whole length is the final velocity. So BC is the final velocity, V. Okay, so initial velocity we got, final velocity we got. I'm going to locate some of the points here. So just to derive the equation of motion, I want to get an equation connecting U, V, S, A and T. That is what my aim. So for that, as a starting, I'm just draw two parallel lines like this. Okay, so I'm drawing AD like this. Now I'm drawing similarly, I'm drawing BE also. BE also I'm locating. Just I draw two parallel lines, which is AD and BE. Okay, now I think it's clear to you. OA is the initial velocity, which is U, and BC is the final velocity, which is V here. Now I am going to write like this. I can write the whole length BC. Whole length BC, I am going to write like this. BD. The whole length BC is the sum of two length BD plus DC. So BD plus DC is for the BC. Now, what is CD? CD, length CD and length OA are equal. So length CD, which will be equal to length OA, which will be further equal to what? Our initial velocity U. So it is, I'm writing like this. Okay, our initial velocity actually in this graph it is 3, but I am giving a name initial velocity as U. So OA actually now it is U. Now I can write like this. What is BC? I already told you BC. The whole length BC is what? 15, which is what our final velocity. So BC is what? V. Instead of BC I can write V. Then what is BD? BD I write BD itself. Now plus what is DC? DC is equal to U. According to this equation, DC is equal to U. Okay, so BC is V and DC is U. Now I'm going to write BD here itself. I'm going to make U to this side. I'm taking U to that side. So plus U become minus U. So V minus U is equal to B. Okay, this is not the first equation. We have to do further on it. Now we have an equation for acceleration. What's an equation for acceleration? Acceleration is equal to when the acceleration comes, when the velocity changes. When the velocity is changing with time, the acceleration comes. So acceleration I can write like this. Change in velocity. Change in velocity by time. Okay, acceleration is change in velocity by time. If initial velocity is U, final velocity is V, what is the change in that velocity? ആദ്യത്തെ velocity 3 ആണ്, final velocity 15 ആണ്. ഇതിലുള്ള change എന്ന് പറയുന്നത് 3 minus 15 or 15 minus 3. Likewise, initial velocity is U. Okay, instead of 3 I am taking U. Final velocity instead of 15 I am taking V. So what's the change in velocity? It is V minus U. So in the place of acceleration, change in velocity, and I can write V minus U. Since velocity, both velocity changes by V. First velocity is U. Last velocity is v. So change in velocity is difference between the both. So v minus u by t, which is the acceleration. So change will be v minus u by time. So if t comes to this side, what happens? Which is at is equal to v minus u. Am I right? At is equal to v minus u. Now v is that side itself. I am making u to this side. When minus u come to this side, it becomes plus u. So u plus at is equal to v. A plus b equal to b plus a. So I can write in reverse order, v equal to u plus at. This is the first equation of motion. First equation of motion is v equal to u plus at. I just write like this, acceleration is equal to v minus u by t. T comes to this side, it becomes at. And when u minus u come to that side, it becomes plus u. Okay, this is for the first equation. I need to write one more thing here. As according to this equation, acceleration is v minus u by t. So what is v minus u then? V minus u is equal to, when t comes to this side, at. Now compare this first equation and second equation. Here it is saying v minus u is equal to bd. Here it is saying at is equal to v minus u. So we can equate what is bd. ഇവിടെ പറയുന്നു bd എന്ന് പറയുന്നത് v minus u ആണ്. ഇവിടെ പറയുന്നു v minus u എന്ന് പറയുന്നത് at ആണ്. അപ്പോൾ ശരിക്കും bd എന്താ? at ആയിക്കൂടെ. So bd is what? at. Here this value we are going to use in the next derivation, which means this length bd. This length is called at. They are giving that length is at. So in this video we derive first equation of motion. At the same time we got a value for bd. Okay, so first equation of motion and we got a value of bd is all. Now I am going to derive the second equation of motion. Here for that I am taking like this. We already know how to find out displacement from a velocity time graph. Here the shape of the graph is like this. Am I right? So this is what the velocity time graph. So how can we find out the displacement? Displacement will be actually area under this graph. So I am going to define two velocity, or I can define time interval, and the area will be, I can divide it into two. Okay, first area will be a triangle and the second area will be a rectangle. Okay, so in order to find out the displacement, you need to find out the area under this graph. So area of this shaded portion. This is what the area. In order to find out the displacement, only you need to find out the area of this shaded portion. So first I am treating this area, this figure, into two. The first figure is of a triangle, and the triangle ADB, and the second figure is what? A rectangle, which is a rectangle OCDA. Okay, so in order to find the displacement, we need to find out the area of a triangle. Next we find out the area of a rectangle. Now we need to add this two. Okay, so I'm going to find out, I wish to find out this second equation of motion. So I'm going to find out the displacement. In order to find out the displacement, I need to find out the area of triangle ADB plus area of rectangle OCDA. Okay, how to find out the area of a rectangle? Area of a rectangle. This is our rectangle. Am I right? Rectangle A, D, B. How to find out the area of a rectangle? Half into BD into half into base. Base is what? The AD. AD into BD. What's an equation? Half into base into altitude. Am I right? So here half into base is what? AD, and altitude is what? This length, BD. Okay, so in order to find out the area of a rectangle, we need to find out half into AD into BD. Okay, so what is half into? So area of a rectangle, triangle ADB. Area of triangle ADB is equal to half into, what is AD? AD and OC are equal, which is given by time interval. What is what? T. Okay. AD, which is further equal to OC, which is what? Time T. So I can write like this. AD, instead of AD, I can write T. In the last derivation, we got BD. What is BD? Which is 80. Okay, so the BD already we got from the last derivation. So half into T into 80, which is 80 square. T into T square. So area of triangle is half into base into altitude. Base is what? This length, which is time. And altitude is BD, already we got, which is 8. So area of triangle we got like this, half into 80 square. Now we want to get the area of the rectangle. Okay, so how to find what's the area of the rectangle? We have the rectangle like this, O, C, D, A. Okay, so area of rectangle is length into breadth. Length into breadth. Here length we can take it as OC. Breadth we can take it as OA. What is OC? OC I already told you. OC and AD both are T. Time interval. So OC is T, and what is OA? OA is what? U. So area of rectangle. What's the area of rectangle we got? Area of rectangle is what? UT. We got it as UT. So how to find out in order to find out the displacement, first we need to find out the area of the rectangle, that is half 80 square. Then we need to find out the area of rectangle, then that is what? UT. We need to, in order to find out the displacement, we need to add both this, which means area of triangle ADB is half 80 square. Area of rectangle OCDA is UT. So area of, that is displacement, comes like this, UT plus half 80 square. Idile UT no. So see children, I am going to derive the third equation of motion. For that, I'm taking the same concept. In order to get the displacement, I want to get the area under this graph. But here I am not splitting the whole figure. I am taking the whole figure as rhombus. So in order to get the displacement, I am taking the area of rhombus. What's the shape of what's the name of rhombus? OCBAO. This OCBAO. OCBAO. So our rhombus is having the shape like this. OCBAO. Okay. So in order to find out the area of this rhombus, already we studied in maths the equation. What is that? So equation is like this, half into sum of parallel side. So parallel side is OA and BC. Their sum is OA plus BC. Okay. Into distance between the side, which is OC. Okay. Now instead of OA, I can substitute what? OA is what? U here. And what is BC? BC is what? V here. Okay. So OC. I want to get OC. Okay. Instead of OC, OC is what? T. Okay. OC already we got it as T. So I'm going to make, we studied the first equation of motion, which is B equal to U plus AP. Okay, I want to get a term in order to substitute for T. Okay, so B equal to U plus AP, and if U comes to this side, B minus U is equal to AP. When A comes to this side, here in the multiplications, with this multiplication side, when it comes to that side, it will be in the division side. So B minus U by A is equal to T. എന്നുവെച്ചാൽ T എവിടെ ഉണ്ടോ അവിടെയൊക്കെ നമുക്ക് എന്ത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം? B minus U by A. സോ ഈ പ്ലേസിൽ, ഈ Tയുടെ പ്ലേസിൽ ഞാൻ എന്ത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാൻ പോവാണ്? B minus U by A സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാൻ പോവാണ്. B minus U by A. Okay, so my equation will be like this. ഇനി നിങ്ങൾക്ക് ഈ ഇക്വേഷൻ കാണുമ്പോൾ ഈ ഇക്വേഷൻ ഒന്നുകൂടി മാറ്റി എഴുതാം. യു പ്ലസ് വിനെ വി പ്ലസ് യു എഴുതിയാലും കുഴപ്പമില്ലല്ലോ. അപ്പോൾ വി പ്ലസ് യു ഇൻറ്റു വി മൈനസ് യു ബൈ എ വിച്ച് ഈസ് ഈക്വൽ ടു അവർ ഡിസ്പ്ലേസ്മെൻറ്റ് എസ് അല്ലേ. ഇനി a plus b into a minus b എന്താ? a square minus b square. Likewise b plus u into b minus u is equal to, എങ്ങനെ എഴുതാം? b plus u into b minus u, b plus u into b minus u നെ we can write like b square minus u square. So I can write like this, b square minus u square by a. Okay, so my equation will be like this, b square minus u square by 2a is equal to s. 2 is common to both. Now when 2a comes to this side, b square minus u square is equal to 2as. I can change the sign. So b square minus u square is equal to 2as. This is what the third equation of motion. So first equation, b equal to u plus at. Second equation, s is equal to ut plus half at square. And third equation, v square minus u square is equal to 2s. In all these three equations, you can see only these terms. How many terms? v, u, t, a and s. Okay, these are equations of motion. Why we are deriving equation of motion, we will study in next class. Okay.